Good evening. For my problem, we have Drumtight Containers is designing an open-top, square-based rectangular box that will have a volume of 4 inches cubed. What dimensions will minimize surface area, and what is the minimum surface area? So to begin this problem, what we're first going to solve for are the dimensions. So we're going to use two equations. Our first equation that we'll start with is V times S squared times H. Let me just double check that. Yep. So this is our first equation we're going to use. And this is what we'll use to solve for the first part of the problem, which is what dimensions will minimize surface area. What we want to do is we know that 4 is our volume. So 4 equals S squared times H. What we'll do next is we want to isolate one of these unknown variables. So we can just do the H. So what we'll do is divide by S squared, which will give us H equals 4 over S.
Right.
So now that we've isolated one of our variables, what we're going to do is we're going to take our second equation, which I'll write here. This is what we're going to be using to solve for area, which will be area equals S squared plus 4SH. So what we're going to do is we're going to take our H that we've solved for and plug it into this equation, which will give us S squared plus 4S times 4S squared. Do a little algebra just to simplify this, and we'll get S squared plus 16 over, so let me double check, S. So I've written over here that what we get after plugging in our H into the area equation. What we're going to want to do next is take the derivative of this area equation. So I'll write the derivative here, which is going to equal the power rule here, 2s, and then to solve for this one, we have s to the negative 1, which will give us negative 16. Subtract this by 1, which will give us s to the negative 2, which all in all gives us negative 16 over s squared. Laid out, what we want to do is basically find where our slope is equal to 0, which will give us our s. So what we'll do is we'll set this equal to 0. So just to rewrite it, to find, you basically want to just find a common denominator when subtracting. So it's 2s to the cubed minus s squared minus 16 over s squared. Now basically what you can do, just kind of shorten this, is when set equal to 0, we're just finding what number would make this whole equation equal 0. So if there's a 0 in the numerator, then the whole equation would equal 0. So what we can basically do is just take 2s cubed minus 16 equal to 0. And I'll just work this out real quick. 2s cubed is equal to 16 divided by 2. S cubed is equal to 8. Take the cube root. And this will give us an s equal to 2. Now that we've found our s, which is equal to 2, finding our h will be really easy. All we have to do is take this 2 and plug it into the equation that we had for h, which is 4 over s squared. So I'll just plug this in really quick. 2 squared, 4 divided by 4, h equals 1. So to answer the first part of our problem, we have our dimensions s is over here, and h, so it would be s equals 2 inches and h equals 1 inch. Now that we have this, we can simply just take it over to our area, because the second part of the equation is asking what is the minimum surface area. So now that we have the minimum dimensions, all we have to do is just take those and plug them in here. So it'll give us a equals 2 squared plus 4 times 2 times 1. So just work this out. A equals 4 plus 8, and the surface area, the minimum surface area, would be 12. who solved our problem.